over 70 damage mechanisms, types of corrosion industry is battling with, and corrosion under insulation comes invariably among the top topics of the asset integrity. So a lot of pipe failures, especially in Europe, are reported due to CUI. So unsolved problems, and there's a huge opportunity to address this and manage it better with technology. The core problem is when and where is risk going to happen. CorrosionRADAR have invented a technology which is a long-range sensor technology. What you see on the screen is the orange colors are basically wire-type sensors which are about 100 meters long at a time, connects to a data logger with a blue box here, and transmits the data wirelessly to softwares. It can be any software, data visualizations, and RBI softwares, Antea. Good case study here, which is among my favorites as well. Your end user here, they came with a lot of pain that they have to do inspection every few years just because it's a life extension program. They have to do, can we be smarter? Can we inspect it only when needed? So that's where this monitoring came in, and the sensors, the end users have publicized that we have detected using technology, and now we are doing rope access based inspection only on that particular location. So we are managing, we reduce the risk because now we know much better where things are going to be. So officially reduce the risk, extend the inspection intervals, and save the money.
Kind of talked about this a little bit before a moment ago, how CUI data, sensor data can enhance your RBI. It's really pretty clear to me. If you know the environment, it's a known condition. It's either a known condition or it's known that it does not exist. So to me, it enhances your RBI. It's going to improve your inspection effectiveness component of the equation. It's going to improve the quality of the inspection because, again, it's more predictive versus following up later after finding the damage during a turnaround or even while you're up and running. Bottom line is, in advance whether the conditions exist or not. So to me, it has a direct impact on your RBI output. Next slide, please. So how to integrate your CUI monitoring with RBI. So this is basically what we're saying here is being more predictive about your inspection and testing, specifically CUI surveys, CUI inspections, being able to better understand where those conditions might exist. Go ahead and turn the next slide, please. Where those conditions might exist, and being able to focus your energy, your resources directly in those areas. Go straight to them and either remove insulation or use profile radiography, who knows, using different technology to actually detect said CUI. So when you actually use this asset integrity management platform as a hub for all these data inputs, including the sensor data, you're actually creating a bridge between what we call your IT, information technology, well, that's your legacy systems like SAP, Maximo, Upkeep, any of your ERP, EAM, or CMMSs, and then connecting that to the OT world, your PI data or data historian, DCS, PLC, or SCADA, being able to be the bridge in the middle and collect all this sensor data to where you can actually analyze it and make decisions in a single place. It's basically how you create the digital twin. Next slide, please. This slide here covers the same information. It's really about connecting your IT to your OT, but it's also about bringing, as I mentioned a while ago, humans as a sensor is an example, Prafull. I call them humans as a sensor. Really, we're all collecting data at some point, right? You got operators out there doing operator rounds, and they're documenting things that are happening. You got maintenance technicians out performing maintenance on these assets, and they're documenting things. We also have non-destructive testing technicians. We've got inspectors. Everybody's collecting data. So really we're acting as a sensor. And in many cases, we're using one of the 4 dimensions of mobility, whether it be a smartphone, a tablet, or wearable technology. Either way it goes, we're sensors collecting data, but also pulling in all that non-destructive data straight from the devices themselves. So really it just closes a loop on every bit of data that's associated to any given asset throughout its life cycle in a facility and bringing it into one space so that one might take actionable decisions.
I like your analogy of human as a sensor, because we have the best sensor in the world, eyes, ears, and the brain, estimations. But there are limitations. We can't see under the insulation, for example.
Yep,
And
you're
that's where we have
exactly
to
right.
augment. Yeah, that's where we have to augment with all these sensor technologies, X-rays, for example, pulse rate currents, and monitoring technologies like sensors. Where our limits, human limits are, can we augment with technology and use a better decision making?
Yep, you're exactly right. It takes both. It takes humans for a lot of decision making, but also it takes the data itself, the sensor data, to actually be able to give the humans something to analyze. And then also some of the future things we're working on here are adding some AI features and artificial intelligence features and machine learning features along with the analytics aspect of it.
Yeah.
Next slide. So we talked about digital twins a while ago. We're calling this digital twin 2.0 because we're actually introducing information or data that has never been introduced into a digital twin. We've talked here a few weeks ago about the another partnership with Clean Connect, where we're bringing computer vision into the platform using optical gas imaging technology to actually not only detect but identify and quantify emissions, fugitive emissions in the plant. Now we're talking about bringing in CUI sensor data to actually be able to understand where CUI is highest risk in the plant based on that sensor data and the analytics associated to it. So doing things that most digital twins really don't do. We're calling it digital twin 2.0.
That's a great term, digital twin 2.0. And in many ways, Floyd, this is again, in the nature, there are so many examples. So, this is industrial world, but in the medical world, a lot of these things are getting used. Doctors use a lot of tools, X-ray, ultrasonic, to understand the human body, and then they use a lot of analytics tools, digital tools, right? But the key difference there is, compared to human body and the industrial world, that the industrial world does not have a nervous system which tells them that hey, there's a problem, right? To go to a doctor altogether. In the industrial world, sensors are needed as a nervous system to tell that hey, there's likely a problem. We don't know how severe the problem is. Just attend to it. So that's where the opportunity here is in the CUI monitoring, connecting it to digital twin, and make it more closer to a kind of natural world which we all exist in.
Yeah, that's exactly right. As a matter of fact, a lot of the technologies that we use today come from the medical industry and vice versa. But one point to make here is that these sensors make it possible for, as I mentioned a while ago, for the asset to actually speak to us. A doctor can speak to a human. Humans can respond and say, hey, it hurts when I do this. And the doctor says, don't do that. Bottom line is that you can actually talk to the human and determine, what's going on and help to better focus in on what the real issue is, what the pain is, in order to make a diagnosis and, of course, prescribe something to fix it. Well, using sensors, we're able to do the same thing with the asset itself, with the equipment themselves. It can actually speak back to us and tell us what condition it's in, tell us what what its temperatures, pressures, moisture, whatever the case may be, so that we can better understand how we can help it have a longer lasting life, improve its life cycle.
Learn from the nature.
Next one. So we talked a little bit about humans as a sensor a moment ago. So we're going to talk a little bit about the driver for remote access to data. So accessing real-time data nowadays, we can do from our mobile phones, from our tablets. All this information can be connected using connected technology to actually access the information and help make decisions, no matter where you are, whether you're at the plant, whether you're in downtown Houston at your corporate office. It really doesn't matter. One thing you can think about is connecting things like with using QR codes. Using QR codes, you can actually scan the QR code and access all the information associated to that specific asset. And at the same time, if you're integrated to your CR data, to your corrosion radar data, you can actually access the CUI information. Now, this is really huge when you're planning work, when you're actually doing activities in a plant, because you don't necessarily have to be there in order to plan it. Here, you can actually visualize the assets and actually do planning, like planning for scaffolding, where you see a high potential for the CUI to exist. You want to be able to plan for scaffolding. You want to be able to plan for maybe staging equipment or staging materials, new installation materials, what have you, or maybe it's a rope access plan. But all this can be done right there through a digital twin, and could even be done from your smartphone or tablet.
I think one of the aspects here is, time to respond or time to gain information here, because many of the inspectors or many of the engineers, they have to visit plant, and if they have some information missing, they have to go back to their offices. That loop is time consuming, right?
It
I
is.
am right now, Floyd, I'm right now in the Middle East, visiting some plants, and the asset integrity engineers have a hard time in summers going out, and coming back. The plants are huge, and the weather is not helpful, right? So if you can save them time, they're happy. So I think mobile technology, getting information right at the asset level when they're visiting the site rather than going back and forth between offices is a huge advantage.
Yeah, it actually connects to the digital transformation journey. And note, I did say journey. Digital transformation is not an event, it's a journey. And I can remember back in the day when I was just an inspector, contract inspector out at Exxon, and having to go all over the place just to find all the data you need to do something like, I don't know, a re-rate or maybe a repair. Some of the data would be in the maintenance shop, some of it would be in operations, some of it would be over in engineering, and it just take you days to come up with all this information. However, through that journey, most folks have come to a point where they're at least digitized. Not everybody, but most are at least digitized. That means their data or their documentation is in digital format in a shared drive someplace. Now, in most cases, there's still a data silo there because not everybody has access to that shared drive, right? So to me, creating this bridge between the IT and the OT is ideal in terms of time to find, because all of the information associated to any given asset throughout its entire life cycle is right there in that same space for anybody to access. Of course, permissions have to be set. Some people can actually influence the data. Some people can actually can only read the data. So, but still, it's valuable to everyone. And remember, I mentioned that $1.8 million per year in savings for an example of a facility with 1,000 fixed assets, meaning just pressure vessels, exchangers, towers, not considering piping, just 1,000 assets, $1.8 million a year. That's huge. That's huge to drop onto your bottom line at the end of the year.
So Floyd, so some of the attendees might be thinking that, these devices, many of the companies have policies. Obviously, we're dealing with hazardous locations, and the devices may not be, allowed there. So are there ATEX or class 1, Div 1, Div 2 rated devices available?
So, you can use specialized tools, but you also have cases, these certified certified cases that you can use that are acceptable as well. One of the companies, I'll just off the top of my head, is Joy Factor, that makes these things. You can actually just put your smartphone in if it's an Android or an iPhone. Same for tablets, and that makes them where you can actually take them out into facilities. It's becoming a lot more commonplace nowadays, simply because everybody's collecting data through mobile apps nowadays.
Yeah, thanks.
And what are the life of and warranty of the coal sensors?
Right, the CUI sensors. So CUI sensors, they're normally between 15 and 20 years life, but inherently we have a moisture sensor and corrosion sensors. Corrosion sensors are like, it's a coupon, it's the longest coupon in the world. If there's no corrosive environment, it should last 15 to 20 years, but if there's a corrosive environment, the coupon will corrode at a particular spot. So that, but the other spots, other locations of the sensor will continue to work as it is if there's a dry environment, and multiple spots can be detected. And then if it needs to be refurbished, a part of the sensor can be changed and removed. So say 1 meter length sensor can be removed and reconnected. So yeah, that's the answer.
So one thing to mention too, I see another question here around that intrinsically safe is, yeah, there's a lot of plants that won't allow you to use your smartphone or tablet in the plant or in the unit. In many cases, that's changing, that's evolving over time here. But also you have to consider there's also, as I mentioned, there's cases, actual cases that make it intrinsically safe and where you can actually carry it anywhere. So that's a response to that question there with regard to ignition sources and mobiles in the plant.
Yeah.
Okay, we also have another question. How specifically can we know this is a CUI and does not interfere with other types?
Yeah, so I think in the sensor side of things, if it is so there are two sensors. One is water. Water is water. I mean, detects water. And the second sensor is corrosion sensor, which is corrosivity. So this gets installed under the insulation. Now, it doesn't have to be a kind of specialized condition. It says about corrosivity, whether there is a corrosivity in that location or not. Now, it does not mean that there's a CUI existing right now, because there might be coatings. It's all about knowing the risk. So it's not about distinguishing different corrosion mechanisms here. It's about knowing that there's a corrosive condition getting developed there at a particular location under the insulation, and it's worth looking at it from the risk point of view. So that's how we see it. The sensors are basically corrosivity sensors and moisture sensors.
Okay, thank you. Are the sensors hardwired or remote sensors? Does this require the vessel to be entirely stripped for install? Can these be added to existing assets?
Yeah, I mean, the sensors, they are retrofitted in brownfield applications. Obviously, insulation needs to be removed when there is a existing inspection going on. Greenfield is a different question. It is part of the design in many cases. Many of our end users are using in the design. But the brownfield application, it's when the insulations can be removed. For example, cold duty insulations are removed during inspections, and it need not be done for the whole asset. It can be done only on critical locations which are prone to CUI, and the end user wants to know whether the assumption is there's a prone to CUI, but is it really a right assumption? Can we skip the inspection? So that location can be covered, critical pipelines can be covered, and the installation is done usually removing the insulation in brownfield during a turnaround or during a inspection interval.
Okay, and then the technology can be adapted for all sorts of insulation, irrespective of density.
I guess this is a sensor question, and I believe RBI question will be with you anyway, Floyd. So sensor point of view, there's no limitation on the type of insulation here. It can be mineral wool, glass wool, and it can be foam glass, it can be cryogel, silicate. Insulation doesn't matter. What matters is technology works in all the cases. Water is detected using moisture sensor. Corrosive conditions are detected using corrosion sensor. It's more about where to apply and when to apply. The limitation of insulation is not limited. So I think I guess the question was on the technology. So I don't know whether RBI or risk. There's a question on that.
No, you covered it. I think the main thing to understand is that the actual sensors are installed in contact with the substrate. So the insulation is on the outside of that. Doesn't matter what kind of insulation it is.
Yeah. And just to elaborate on that, the sensors need not be in contact. There's no technical reason why the sensor needs to be in contact with anything like even a pipe or metal surface. They are basically independent sensors. They're kept on the table. That even that works. You put it on a table, put water, it detects water. So that's the core. And if it is, in many cases, the sensors were installed in an end user case where it was not in direct contact with the asset, but close enough, but after a layer of insulations, because the end user said, okay, the temperature is too high. We don't want, the sensor temperature limit was 300, but the asset temperature was about more than that. So you put, okay, there's a layer of insulation in between the sensor and the asset. So just to protect the temperature to the sensor. So that's the technical advantage there.
Yep.
Okay, we're getting a flood of questions.
So a lot of good questions, Floyd. Looks like we have covered a good ground. I confused a lot of people, but that's a good confusion. Good problem to have.
Yeah, I think also if there's any questions that we don't get to, we'll certainly respond to them after the webinar. We'll respond via email. So the difference
Yes, I think
in this
that's
technology,
about.
there's one here that talks about long-range guided wave ultrasonics. This is not ultrasonics. This is actually sensors that are measuring for corrosivity, or sensors that are measuring for moisture, these sorts of things. Long-range guided wave ultrasonics is specific to send a longitudinal torsional wave down the pipe in order to look for anomalies in that distance, in that length of the pipe. So two different technologies.
Just my addition to that, I'm a fan of ultrasonic guided wave as well, but the limitation, it's an inspection technique. It's a lagging indicator type methodology.
Yeah.
Obviously, it is needed. We are not eliminating that by adding monitoring technologies, because inspection is still needed. We're just managing the risk much better. That's how it is. It's all the tools are to be used to manage the risk better. So in this case, as you rightly said, guided wave ultrasonic is inspection technique, but through monitoring, we can tell when and where to inspect and do the guided monitoring rather than doing guided wave ultrasonic everywhere, because it's also expensive method to inspect as well. There are limitations as well. And what we use, it's a similar philosophy. The monitoring is in the form of a wire. We don't use pipe as a waveguide, but we use sensor as a waveguide. And then sensors are embedded, but we use microwaves, electromagnetic. But the similarity is it's both uses time of flight. You send a pulse, and then wherever the defect is, the pulse gets reflected. So similar philosophy, but slightly different philosophy as well.
There is a question here. Is there any possibility data error from the sensor? If yes, what will be the variation range? And then also, he asked, some insulation have heat trace. Is there any possible conflict or limitation for obtaining the data and able to send the signal from the sensor?
All right, so I'll
So,
answer the second question first, because the first question I did not really get
Mhm.
it. So second question first. So heat tracers,
okay.
we do a lot of questions on this. So the sensor temperatures are from minus 190 degrees Celsius to 300 degrees Celsius. I say 3 degrees Celsius, sorry, Floyd, because I'm based in the Europe, right? So from the UK,
Right. Right.
Fahrenheit, I have to do a lot of mental math to do Fahrenheit. So
Yeah.
minus
Right.
minus 190 degrees Celsius to 300 degrees Celsius. Now, if the heat tracers are above 300 degrees Celsius, then ideally we have to put a layout where the sensors does not touch the heat tracers. If they have to cross over, then we put a small layer of insulation so that they don't contact between them. Now, if it is below, the heat tracers themselves are below 300 degrees Celsius, no problem. The sensor can be in direct contact with that. So, Angela, can you repeat the first question, please, on this?
Is there any possibilities there's data error from the sensors? And if yes, is there a variation range for those data errors?
Yeah, I mean, it's the other way to say that is probably false calls, or unknown spurious signals. Um, it's a good debate in the industry as to what we can live with. Now, in kind of sensors and monitoring technologies always battle this. It's a battle between the signal to noise ratio. What is a good signal? What is a false call? In one of the cases, we had an issue where unknowingly one of the technicians, during refurbishments of the insulations, they cut the sensor, they damaged the sensor. Now that can be regarded as a false call, that sensor detected something. We don't know quite yet what it detected, but it was a very sudden event. Suddenly it detected that there's some signal. Now investigations led to the conclusions that okay, actually that was cut damaged by mistake. So this is an example of false calls. It does happen. I won't say it's a 0%. So there's a certain percentage, but not a whole lot. In another example, we noticed that the end user, the asset owner, the integrity people assumed a certain temperature range of the asset, say about maximum 250 degrees Celsius during operations. But then there was a signal came in that hey, something was detected and it is unusual, when the experts looked at it and from the signals, and then we realized that no, the sensor have been damaged, and probably likely due to thermals. So the temperature went above the temperature limits which the design engineers or the asset integrity engineers knew of. Probably it went above 300 degrees Celsius, 350. So the sensors got damaged. So these are the examples where off limits, unknown cases, the signals can be spurious, and so experts have to look at it in those cases. It was a great conversation, Floyd, and as always, enjoy the conversations, and all these new techniques are actually bringing a change in the industry. So we represent the industry together and the community of corrosion and asset integrity engineers. So a great conversation with you, as always.
Thank you so much, Prafull. I've really enjoyed
Thank you
talking
so
with you as well.
much.
We'll talk again soon.
Thank you, Angela.
Take care.
Take care.
All right.
Bye-bye.